Hello, Nora, fourth graders, Mr. Hoffman, and I'm going to give you a quick little rundown of some of the different types of graphs and how we use those graphs. And then you're going to use the lesson today to kind of make a couple decisions about data and how to graph that data and move forward into a data collection project. And so there's going to be some slides in here that I'm going to skip over just because to save you guys some time, I'm going to go through all the different graphs that we're going to learn today. So you have an understanding of what those graphs are. And then after the lesson, you can go through and work on an activity to create your own graph to represent a selected set of data. So it's going to be your job to kind of say, okay, I looked at all the different types of graphs, given the data that I have, what is going to be the best form of a graph to use to create that data or to show that data. And then you're going to make your own graph using that data set. So let's start with tally marks. So tally marks are super simple. We don't usually use tally marks as an actual graph, but sometimes it's a way to collect and mark our data and then transfer that data into a graph. So if you look, you have a little tally mark graph here of favorite zoo animals. And it says tally marks are simply a line we use to mark a piece of data, right? So if I'm collecting data and I go to somebody and say, hey, what's your favorite animal? At the zoo, they say tiger. I would mark that with a tally on my chart. Or maybe I've given them a select 4. You have a choice between a tiger, giraffe, elephant, or deer. Of those 4, which are your favorite? And they tell me elephant. So I use the line to mark elephant. You're really just collecting data with these little lines to show the number of answers. And the only really tricky part probably about tally marks is that the 5th tally is marked with that little diagonal line, right? So if you look at tiger, I've got 1, 2, 3, 4, 5. And the reason we do that is it makes it easy to count by 5s. I can see that right here is 5 tally marks. So when I'm counting the tiger, I can just say 5, 10, 15. Or if I go down to the deer, I can say 5, 10, and then one more is 11. So again, tally marks are just a way for us to mark and show data, and then it kind of helps us use those tally marks to put our data in a more organized display that might show things a little bit more accurately, or not accurately, but more detailed. So for example, I could take those tally marks from those zoo animals and move them into a bar graph, right? And we're going to talk more about a bar graph here in a second, but you can see that like now this is all the exact same data I just had about the favorite zoo animals and tally marks, but put into a bar graph so you can kind of see it laid out with these actual bars of which was the favorite and by how much. So let's talk about the parts of a bar graph. In general, every graph is going to need a title, right? Is this part up here, vehicles at the parking lot? The title is just a little section that shows us, hey, this is what this graph is all about. Then over here on the side, you're going to have what we call a scale. So if you notice on this bar graph scale, it jumps from 0 to 10, and the halfway point would be 5. Depending on what data you're collecting, your scale might be 1, 2, 5, 10. You make the scale. If you have data collected and it goes up to the number 50, you're probably going to need a larger scale like this one. If you're only going to 10, you could use 2, 4, 6, 8, 10. Scale just depends on what you need to do, right? The axis title is down here at the bottom. It's the body type, meaning the type of the car. This is just saying that minivan, sedan, truck, coupe, and SUV, those are all the body types of a car, and that axis title is telling us what those little things mean. On this side, you've got the data bars, right? These are just the actual bars of data that show, for example, truck, my bar goes up to 10. So 10 of the vehicles in the parking lot are a truck. If I go over to minivan, I can go 10, 20, 25. 25 of the cars in the parking lot are a minivan. I'm using those bars to match them up with my scale and tell me. And the last thing is the graph labels. These parts on the bottom are just the labels on the graph that show us what each bar actually represents. So let's look at some questions about bar graphs and how you can answer them. So letter A right here says, how many people preferred spring or summer? When you see that word or, and it's talking about data, it means I could choose like either of them. So I'm going to count both bars, right? So look over here, I have spring is 60. So I'm going to actually use my pen and write that down. So there's 60 people who chose spring. And then if I look over here at summer, I can go 90, and then halfway between 900 is 95. So how many people preferred spring or summer? I'm going to add that 60 and that 95, and I'm going to get 155. So 155 people preferred spring or summer, right? I'm going to skip down to C now, and it says find the difference between the seasons that receive the highest and lowest votes. So if I'm finding the difference, I'm subtracting, right? Summer is the highest votes at 95, and the lowest number of votes was winter at 25. So I'm going to do 95 minus 25. 5 minus 5 is 0, and I'm going to have 70 people, right? So I can use those different bars to look at the data, analyze the data, and answer very specific questions about that data. That's bar graphs, right? We're also going to look today at what we call pictographs, which is where you have pictures that represent a piece of data on the graph. So let's talk about a pictograph. The top, just like before with a bar graph, you have a title. The title of this one is Apples Sold. Pictograph pictures is how data is represented. So in January, this apple represents an amount of data, right? Excuse me. You also have a graph key that shows the value of each item on the pictograph. So if this apple right here represents 10 apples, in January, there were 10 apples sold. The tricky part here is what if I have a half of an apple? Well, that means it's half of whatever the scale says. So if the value of one apple is 10, then half of the apple in March is 5. So when I'm looking at the number of apples sold in March, I would count 10, 20, 25 apples, right? So that's just a way of using this scale to kind of look at the pictures and understand what they represent. So let's look at answering some questions. If I'm looking at this pictograph, I can see down in the key that my smiley face represents 4 students. So on these, half a smiley face is going to represent 2, right? So the first question says, how many students ride a bus to school? So let's look at bus. I've got 4, 8, 12, 16, 20, 24, and 2 more is going to give me 26 students. So I'm using that key on the graph. I'm using that key on the graph to help me make that decision. How many students either take a car or ride a bike? So now, or remember, going back to that language, that means it could be car or bike. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40 people, right? 40 students. And then number 3 says, how many students are represented in the graph? That means I'm going to count every single one of these people that's represented. So 4, 8, 4, 8, 12, 16, 20, 24, 26, 30, 34, 38, 42, 46, 50, 54, 58, 62, 66, 70, 74, 75, 76 students are represented, right? I'm using that key and I'm using those pictures to identify the number that represents each category. I also have what we call a line graph. Line graph, very similar to a bar graph. You have almost all the same thing. You have your graph labels down here with your x-axis label. You have your data representation in a line though, instead of bars. You've got a title and a graph scale. It's all pretty much the same pieces as a bar graph, except line graphs are showing how data changes over time. So you can see that this data goes through a week: Monday, Tuesday, Wednesday, Thursday, Friday, right? It's going throughout the week. We can see over here on the graph scale that this is the number of hot dogs that were sold per day. So they jumped by 10, just like that. Just like a bar graph, my line graph is showing me those numbers, except it's got lines to show how things change over time instead of bars. So you can see I started with the least amount of hot dogs sold on Monday, and Friday was my busiest day. So it's just like a bar graph pretty much, except it's showing change over time, and the dot on the line shows the data rather than an actual bar. So let's look at I'm going to do 2 of the questions. It says, how many hot dogs were sold on Friday? I'm going to go to my Friday. There's my dot. I go straight across. I can see that it's 70, right? 70 hot dogs were sold on Friday. Which days had the same amount of hot dogs sold? That's where these 2 dots are the exact same spot. That would be Tuesday and Wednesday. That's a line graph. Again, I'm not going to spend a lot of time because it's just like a bar graph, and I think you guys probably get it. Last thing we're going to talk about is circle graphs, and there's going to be 2 different kinds. One is where they're going to ask you things about a fraction, right? And so let's talk about there's 3 really main parts you need to know about a circle graph. That is the title. You've got the circle with the pieces of data that are represented, and then a key over here that shows what each part of the circle in color represents. Sometimes you're going to see it just presented like this, like a fraction, right? And we can see if I make a T that this is really like saying I have 4 right here, there's 1/4, or there's 1 divide, 2 divide. It's like saying each of these sections is 1 out of 4 pieces, right? So I have 1/4 here. Oops. I have 1/4 here. I have 1/4 here. And then each of these pieces is also 1/4 of the chart. Sorry, guys. I don't know why it's being so difficult. So each part of this graph is representing 1/4. So then when I look at the question number 1 about what fraction of the circle graph is basketball, I can see basketball is blue. My answer is 1/4. What fraction of the graph is soccer? Soccer's pink, right? So over here I can see that it's 2/4. Or another way of saying that is 1/2. That's about half the graph. About what fraction of the graph is either soccer or football? So 1/4, 2/4, football is green. 3/4 would be my answer for that question, right? So that's when it's represented as fractions. You also will see circle graphs that are represented, sorry, I'm skipping around again, as percentages, right? So let's look at this one about percentages of the movies, favorite movie types. Notice down here, sometimes it'll say something like there were 200 total people surveyed, right? So when there were 200 total people surveyed, what that's saying is that this represents 200 total people. Each percentage part is out of 100. So if I had 50% out of 100, that means 50 out of 100 people. If I have 10% of 100, that means 10 out of 200. So basically, since there were 200 total people, if I want the actual number, I'm multiplying each of these percentages by 2. So 50% times 2, because there's 200 total people, would mean 100 total people chose comedy. 50% of the whole 200 chose comedy. So that's actually 100 people. You're not going to see that happen very often, but it does happen, and it makes things a little difficult. So you've got to pay attention to what it says, how many people were surveyed. So let's talk about a few of these questions. And then when we're done talking about the questions, we'll move on with the assignment. So when I look at these questions over here on the right, like using the circle chart, when it asks what's the most popular movie genre, I just have to find the biggest chunk of that to find the most popular. I can clearly see that half the chart is comedy and everything else is a smaller section. So my answer to that question like that would be comedy. Here is one of the more complicated questions you're going to get because of the way this scale has 200 total people surveyed, right? The bottom one says, how many students chose romance as their favorite form of movie? So if you look, romance makes 15% of the whole pie chart. But because it's out of 200 people, not 100 people, right? Because 15% means 15 out of 100. I have to say, well, I have 200 people. So I have 15 out of 100 plus 15 more out of 100. So my answer to that question is not 15%. It's actually 30 people. So those are the most complicated questions you're going to get about a circle graph because it's asking you to give the actual number and not the percentage. Most of these other ones you guys can probably do pretty easily. What percentage are drama, romance, and action combined? We know we just need to add drama, romance, and action, right? So action is 20%. So I'm going to add 20 because it's asking me what percentage, right? Not what number. That's another tricky thing. You'll have to make sure you're looking at the percentages versus the actual number in the questions. So I'd be 20% for action, romance is 15, and then drama is 10. So I'd be doing 20 plus 15 plus 10, and I would get an answer of 45, right? So these questions like this about circle graphs, you're just got to make sure you're paying very close attention to what each little number means and what percentage it's asking for, depending on whether it says what percentage or how many students, right? How many students implied the number, what percentage implied using the actual percentage on the graph. So now that you've had a quick little rundown of what each type of graph is and how you can represent data on those graphs, we are going to give you a collection of data, just a random thing of data with a title and the numbers or the answers to people's questions about the data below. Your job is to use a plain white piece of paper to look at that data and think about what is the best way to represent this data. And then you're going to create your own representation of that data. So whether you want to make a circle graph or a bar graph or a line graph, you should stop and think about, okay, if I have this data, what is the best way for me to represent this data based on the graphs I've seen? If you need to go back in the video and rewatch any part of the lesson to look at what kind of graphs represent what data, that might be a good idea, but ultimately it's your choice. After you have finished, you can submit two ways. You can take a picture or a video of that graph and submit it that way, or you can type up an explanation of what you chose and why you chose it, and you can turn the actual graph and paper into your teacher. So those are your couple of choices of how to submit the assignment. Good luck, you guys, and we're looking forward to seeing what you come up with and how you represent the data.